Hi, class. This is Dr. Lindner. We are continuing with our topic on chemistry. Now, this is not the most exciting lecture. It's kind of like on the boring side. I will admit, not the most exciting, but the information is very important. I'm going to give you some of the building blocks to chemistry. We're going to talk about um, atoms and mass and atomic number and atomic mass. We're going to be talking about electrons, neutrons, protons. We're going to talk about different types of bonds, ionic bonds, which are very important, covalent bonds. We'll talk about chemical reactions, and then we'll get into organic and inorganic compounds. So it probably gets more intriguing and interesting when we start talking about the organic molecules and like proteins and fats and carbohydrates, and then we get into water. It'll get a little bit more intriguing. So bear with me. Please don't hate the messenger. We will get through this together. And I'm not trying to make us biochemists. I'm trying to give you really the basic foundational understanding that I think is important. I'll try and throw some hints here and there as to what I think is important or what you may see on an exam. So let's start with that. Okay. So atoms, when we talk about atoms, they're the chemical elements are composed of units of matter of the same type called atoms. And these atoms are the smallest unit of matter. They're the smallest units of matter that retain the properties and the characteristics of an element. So when we look here, we see a bunch of what we call shells or valence shells or clouds. Sometimes they're called electron clouds. And in the center over here, we have this nucleus. And the nucleus is made up of protons and neutrons. See, that makes up the nucleus. Now, you may have heard, like, if you're in a relationship, they'll say, oh, opposites attract, right? If you're too much with the same type of person, you'll get sick of them very quickly. And that's true. It really is true. Opposites do kind of draw to one another. Or you may have an optimist that kind of is drawn to a little bit of a pessimist, and they kind of are drawn to each other and attracted to one another. The opposites do like each other. They draw in the same direction. But when you have two positives or two negatives, they repel. It's kind of like if this was a magnet and it had a North Pole and a South Pole, and over here I had a North Pole and a South Pole. What would happen if I try and bring these two together? You'd feel this force that actually does the opposite and it pulls them apart. Opposites are not drawn together. But if I did it the other way, like this, and I had a North Pole and a South Pole and a North Pole and a South Pole, these would be drawn to one another and they would stick. Opposites attract. So when we look at a nucleus that's made up of protons, protons have a positive charge, whereas electrons have a negative charge. So if you have a bunch of protons surrounding the nucleus and you have a bunch of positive charges there, what happens when we bring two positives together? They repel, they pull apart, and we don't want to pull apart the nucleus, so we buffer that with a bunch of neutrons. We put a neutral charge in there to act as a buffer so that these positive charges don't rip the nucleus apart. So the protons and neutrons make up the nucleus, and the electrons are hanging out in what we call electron clouds or electron shells. And typically the outermost is referred to as the valence shell, the valence, the outermost. Okay, just some basic stuff. Now, the atomic number, let me just move this out of the way for me. There we go. The atomic number we see here, the atomic number is the number of protons. What type of charge do protons have? They have a positive charge. Okay. The mass number is the number of protons and the number of neutrons. Now, typically, the number of protons that you have is going to equal the number of electrons. So if you have an atomic number of 6, and that's the number of protons, and you have 6, how many electrons should you have? The same number, 6. 1, 2, 3, 4, 5, 6. Okay, they match up. When we look at an atomic structure, let's look at some of the biggies that we will see. Hydrogen, carbon, oxygen, and nitrogen, right? After all, this makes up about 96% of the human body, right? These elements. So hydrogen has an atomic number of 1. Now, the atomic number is the number of protons. So how many electrons do we have? 1. Carbon has an atomic number of 6. So we have 6 protons. How many electrons? The same amount. 1, 2, 3, 4, 5, 6. Nitrogen has an atomic number of 7, 7 protons. How many electrons do we have? Should be 7. 1, 2, 3, 4, 5, 6, 7. Oxygen has 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, 8 protons. That's how that works. Now, there's others that we're going to be looking at as well. We're going to focus on sodium and chlorine, because somehow these two come together and form a nice tight relationship with one another. And when they come together, it usually looks like this: Na plus Cl minus, and that's salt, sodium chloride. Sodium chloride is table salt. We'll go over what the plus is for and what the minus is for, but they create some sort of bond together. Sodium by itself is a poison, and chlorine by itself is a poison. We don't want poisons in the body, but when they come together, we have something that's essential. Isn't that amazing? By itself, it's poisonous, but together, it's essential for our living. And I'll explain why these come together, but just make a mental note for ourselves. And I'm gonna, you know what? Let me throw you a little teaser now. Whenever there's an outer shell, for stability, there should be 8 electrons in the outer shell. So how many electrons do we have in this outer shell? There's only 1. That's not stable. Over here, we have 1, 2, 3, 4, 5, 6, 7. That's not stable. So by themselves, they're unstable and they're poisonous. I'm just going to say that much for now. But together, when they come together, we got something pretty stable. Okay. An ion is an atom that has either lost or gained an electron. Now, an electron is negative, right? Protons are positive. So if I'm losing an electron, let's say this electron, because it's in this outer shell, we want 8 here, but there's only 1. If I say, hey, I want to give this to someone, maybe I'm going to give it over here. So sodium is losing an electron. So if you're losing some negativity, if you're losing that electron or that negativity, wouldn't you agree that you're becoming more positive? You got a negative friend and you lose that negative friend, you just become more positive, right? So that's why we see sodium with the positive charge. Now, it gave an electron to chlorine. So we're going to add one here. And now, how many electrons does chlorine have in its outer shell? 1, 2, 3, 4, 5, 6, 7, 8. Hey, that's stable. That's looking good. That's looking really good. So this lost an electron, gave it here. If this gained an electron, it became more negative. That's why we put the negative there. It tells you whether it was an electron donor or an electron acceptor. If you're donating an electron or losing one, you're becoming more positive. If you're gaining the electron, you become more negative. So an atom that has lost or gained an electron, that's an ion. And that's why when we look at salt, we say it's iodized salt or ionized salt, because salt goes through a process of ionization. There's a losing and a gaining relationship there. So you can remember this little silly thing called an oil rig. An oil rig is, see if I can remember it, oxidizing is losing an electron. Reduction is gaining an electron. Oxidizing, when something becomes oxidized, oxidation is losing an electron. When something is becoming reduction or reduced, reduction is gaining an electron. So you can lose electrons or gain electrons in the process of oxidizing or reducing. All right, what's a molecule? A molecule is when you have two or more atoms that share electrons. So we can lose electrons, we can gain electrons, and sometimes they hold hands and they just share, they connect. They're sharing electrons. A compound is a substance that could be broken down into two or more different elements. Okay? A compound is when you have something and you can break it down into two or more different elements. So when I go through chemical reactions, we'll look at a bunch of compounds and see how they can be broken down into two or more different elements. Okay, good place to take a break. When we come back, we're going to get into chemical bonds, and we'll talk about electrons. We'll talk about the octet rule and stability of these electron clouds.